For most of human history, Earth felt like the exception. A single, rare world where life somehow took hold. Liquid water flows across its surface. Air moves gently through forests and over oceans. Complex ecosystems grow, adapt, and endure. But as our view of the universe has widened, a quieter idea has begun to emerge. Earth may not be the best possible place for life. Somewhere beyond our sky, there may be worlds that are older, calmer, warmer, and more stable. Worlds where life had more time, more energy, more room to grow. Tonight, we will explore those worlds. There is nothing you need to remember. Nothing you need to follow closely. Let the ideas drift past as gently as starlight. This is a journey through planets that may be better for life than Earth. For a long time, scientists searched for planets like Earth. Rocky worlds, temperate climates, liquid water, but similarity does not always mean optimal. A planet can be Earth-like and still harsh. It can experience long ice ages, violent climate swings, mass extinctions. The idea of superhabitability asks a softer question. Not whether a planet can support life, but whether it can support more life. More biomass, greater diversity. Richer, denser ecosystems spread across its surface. A superhabitable world does not need to mirror Earth. It needs to improve upon it gently. Such a planet would still be rocky. It would still host liquid water. But it might be slightly larger, slightly warmer, and slightly wetter. Not extreme. Just forgiving. Life flourishes when conditions remain stable. Time matters. On Earth, life took billions of years to reach complexity. And even then, it was interrupted repeatedly. Asteroid impacts, volcanic winters, ice ages that reshaped the planet again and again. A truly favorable world might avoid many of these resets. It might offer long stretches of calm, millions or billions of uninterrupted years. In that quiet stability, life does not merely survive. It expands. Planets do not exist alone. They are shaped by the stars they orbit. Our Sun is a G-type star, bright, energetic, and relatively short-lived on cosmic timescales. It will burn for about 10 billion years. But other stars are more patient. K-type dwarf stars, sometimes called orange dwarfs, shine more gently. They emit less harmful radiation. They change more slowly. Most importantly, they live far longer. Some will burn steadily for tens of billions of years. For life, this means time without urgency. A planet orbiting such a star can remain in a stable, habitable zone far longer than Earth ever will. No rushing evolution, no race against stellar aging. Just time. These stars are calmer than red dwarfs, which often flare violently. And they are longer lived than stars like our Sun. They represent a quiet middle ground. Not too hot, not too volatile. For life, this balance may be ideal. Size matters, but only slightly. A planet about 1.5 times the mass of Earth may be especially favorable for life. Its gravity is stronger, but not overwhelming. This extra gravity helps the planet hold onto its atmosphere. Water does not escape as easily. Gases remain bound for longer periods. A thicker atmosphere acts like a blanket. It smooths temperature differences between day and night, between equator and poles. Climate becomes gentler. Storms may still form, but extremes are softened. The planet breathes slowly. Larger planets also retain internal heat for longer. This heat drives geology. Volcanoes recycle nutrients. Tectonic plates reshape the surface. Carbon cycles remain active. Over time, this constant renewal supports life across continents and oceans. Nothing stagnates. Earth's climate is not perfect. Large regions are frozen, others are arid. Life survives there, but it struggles. A superhabitable planet may be just a few degrees warmer on average. Not enough to cause runaway heating. Just enough to expand biologically active regions. Ice retreats. Forests spread. Photosynthesis becomes more productive. Energy flows more efficiently through ecosystems. Life grows thicker. Water plays a crucial role. Earth is about 70% ocean. A superhabitable world may approach 80 or 90%. But not all water is equal. Shallow seas are especially rich in life. They warm easily. They receive sunlight. They create endless ecological niches. Wide coastlines become cradles of biodiversity. Too much water can erase land entirely. Too little dries life out. The most favorable worlds balance both. Earth is about 4.5 billion years old. Some superhabitable candidates may be several billion years older. This matters more than it first appears. Life evolves slowly. Complexity builds layer by layer. On Earth, evolution has been reset multiple times by mass extinctions. A planet spared from frequent catastrophes can follow a smoother path. Species diversify. Ecosystems interlock. Food webs grow intricate and resilient. Over time, life fills every available niche. Older planets may host forests denser than anything on Earth. Oceans richer and deeper with life. Entire biospheres operating at higher productivity. Not because life is different, because conditions allowed it to persist. Among the many exoplanets studied, some stand out. One such world is known as KOI 5715.01. It orbits an older, cooler star nearly 3,000 light-years away. It is larger than Earth. Likely warmer, possibly wetter. Its star ages slowly, offering billions of additional years of stable energy. If confirmed, this planet may remain habitable long after Earth's era ends. It is not close, it is not reachable, but it shows what is possible. A world that favors life does not necessarily favor humans. Stronger gravity would feel heavy. Denser air might be difficult to breathe. Warmer climates could bring constant humidity and storms. Atmospheres rich in methane or carbon dioxide could nourish ecosystems while remaining unbreathable to us. These worlds may be lush, vibrant, and alien. They are not destinations, they are examples. Most superhabitable candidates are found indirectly. Telescopes watch distant stars dim slightly as planets pass in front of them. Others measure subtle stellar movements caused by orbiting worlds. Future observatories will do more. They will analyze atmospheres, search for chemical fingerprints of life. Oxygen, methane, water vapor. Each detection refines our understanding of what life truly needs. The search for superhabitable planets gently reshapes our thinking. Earth is not the benchmark. It is one outcome among many. Somewhere in the galaxy, life may have found easier paths, longer timelines, calmer worlds, places where survival was not as fragile. For a long time, Earth felt like the standard. It is the only world we know that hosts life. Liquid water flows across its surface. Its climate, though imperfect, has allowed complex ecosystems to emerge. But in recent years, scientists have begun to ask a quieter question. What if Earth is not the best possible home for life? What if there are worlds where life could thrive even more easily, with more stability, more energy, and more time? These worlds are not called perfect. They are called superhabitable. A superhabitable planet is not one that looks exactly like Earth. Instead, it is a world that could support more biomass and greater biodiversity. More forests, richer oceans, denser ecosystems. Such planets are expected to be rocky, temperate, and old. Old enough for life not only to appear but to mature. They may be slightly larger than Earth, slightly warmer, slightly wetter. Not extreme, just gently more forgiving. Life depends not only on planets, but on stars. The most promising stars for superhabitable worlds are not like our Sun. They are cooler, calmer, and far longer lived. These are K-type dwarf stars, sometimes called orange dwarfs. They burn steadily for tens of billions of years. They emit less harmful radiation. They offer long periods of climatic stability. Time, it seems, may be one of life's greatest allies. By studying thousands of known exoplanets, scientists have begun to identify candidates. In 2020, researchers highlighted 24 planets that rank highly for superhabitability. None meets every ideal condition, but several come surprisingly close. These planets are scattered across the galaxy, often hundreds or thousands of light-years away. As telescopes improve and discoveries grow, this list is expected to expand. But superhabitable ones may be even more so. Among these candidates is a planet known as KOI 5715.01. It orbits a cool, older K-type star nearly 3,000 light-years from Earth. This planet is likely larger than Earth, with stronger gravity, It receives less stellar energy than we do, yet may still be warm enough for liquid water. Its star ages slowly, offering billions of extra years of stable conditions. If confirmed, this world could remain habitable long after Earth's era has passed. Superhabitable planets are often expected to be slightly more massive than Earth. A planet about 1.5 times Earth's mass can hold on to its atmosphere more effectively. It can sustain geological activity longer. It can recycle nutrients through tectonics and volcanism. Stronger gravity thickens the atmosphere. Thicker air smooths temperature differences. The result is a calmer, more even climate, one that allows life to spread widely. Earth's average temperature is not necessarily ideal. A planet just a few degrees warmer could support more plant growth, more photosynthesis, more energy flowing through ecosystems. Superhabitable worlds may resemble a planet-wide version of Earth's tropics. They may host fewer ice caps, fewer frozen regions, more biologically active land and sea. Water regulates climate and nourishes life. While Earth is about 70% ocean, a superhabitable world may approach 90%. Shallow seas and wide continental shelves are especially rich in biodiversity. They create countless ecological niches. Too much water can be limiting. Too little can be harsh. The most life-friendly worlds likely find a gentle balance. Earth is about 4.5 billion years old. Some superhabitable candidates may be far older. They may have enjoyed billions of years of uninterrupted evolution, with fewer mass extinctions, fewer climatic resets. Over time, stability allows complexity to grow. More niches form, more species specialize. More life fills every available space. A world that is better for life is not necessarily better for humans. Stronger gravity may feel heavy. Denser air may be difficult to breathe. Warmer climates may be humid and storm-filled. Atmospheres rich in methane or carbon dioxide could support life, but not human lungs. Superhabitable worlds may be biologically abundant, yet physically alien. Most of these worlds are found indirectly. Space telescopes measure tiny dips in starlight. Others detect subtle stellar wobbles. Future observatories will study atmospheres directly, searching for gases linked to life. Oxygen, methane, water vapor. Each discovery reshapes our understanding of habitability. Superhabitable planets challenge a quiet assumption that Earth is the best life can do. Instead, Earth may be just one version, good but not optimal. Somewhere in the galaxy there may be worlds older, warmer, calmer, and richer with life. Worlds where life did not struggle as much to survive, and instead had time to flourish. The search for superhabitable planets is not about replacing Earth. It is about perspective. It reminds us that life adapts, that nature explores many solutions, that the universe is patient and generous with possibility. And as we look outward, quietly, slowly, we learn not only about distant worlds, but about the delicate balance that made our own possible. For a long time, Earth has felt like a rare success. A planet balanced carefully between heat and cold, with oceans, continents, and a climate that allows life to persist. But as scientists have studied worlds beyond our solar system, a quiet idea has taken shape. Some planets may be even more welcoming to life than Earth. Not because they are dramatic or exotic, but because they are calmer, steadier, and more forgiving. These worlds are sometimes called superhabitable. A planet's story begins with its star. Many superhabitable candidates orbit K-type orange dwarf stars. These stars shine more gently than our Sun. They emit less damaging radiation. Most importantly, they live far longer. Their habitable zones can remain stable for tens of billions of years, giving life vast stretches of uninterrupted time. A planet that sits deeper inside this calm, habitable zone may enjoy more uniform warmth, fewer extreme climate swings, and a longer window for life to develop. Time again reveals itself as one of life's quiet allies. Superhabitable planets are not giants. They are often just a little larger than Earth. A rocky planet with 1 to 2 times Earth's mass can retain internal heat longer. This allows plate tectonics to continue, recycling nutrients through the surface. Higher gravity helps hold onto a thicker atmosphere. That atmosphere smooths out temperature extremes and offers greater protection from space radiation. With a slightly larger radius, such planets also gain more surface area. More land, more sea. More room for life to take hold. Models suggest that a world just a few degrees warmer than Earth may be especially good for biodiversity. Not hot enough to dry out. Not cold enough to freeze vast regions. A warm, moist, and relatively uniform climate allows life to spread across much more of the planet's surface. Thicker atmospheres help distribute heat between equator and poles, between day and night. With fewer deserts and smaller ice caps, more of the planet becomes usable by life. Water shapes life more than almost anything else. Superhabitable worlds are expected to be somewhat wetter than Earth, but not drowned entirely. Rather than a few deep oceans and vast continents, they may host many shallow seas, archipelagos, and long coastlines. These sunlit waters are among the richest habitats known. They foster biodiversity. They create countless ecological niches. When land and sea are more evenly distributed, barren interiors shrink and productive ecosystems multiply. Many superhabitable candidates are thought to be older than Earth. This extra age matters. Life evolves slowly. Complex ecosystems require time without interruption. On a world spared from frequent catastrophic impacts or extreme climate resets, evolution can proceed smoothly. Species diversify. Food webs deepen. Ecosystems become resilient and layered. Some scientists argue that, statistically, planets quite different from Earth may be better homes for life precisely because of this long stability. These planets are not seen directly. Instead, their presence is inferred from subtle motions. Some are discovered when their stars wobble slightly, pulled back and forth by an orbiting planet. This method, called the radial velocity or Doppler technique, has revealed nearby worlds such as Proxima Centauri b and Gliese 667 cc. Years of careful measurements, tiny shifts in starlight, and patient analysis slowly bring these planets into view. To compare worlds, scientists sometimes use a number called the Earth Similarity Index. It ranges from 0 to 1. Earth, by definition, is 1. The index compares basic physical traits: size, density, gravity, and temperature. Some planets score very highly, nearly Earth-like in shape and scale. But similarity is not the same as habitability. A planet can resemble Earth and still be harsh, unstable, or unwelcoming to life. The index is a guide, not a promise. Planets like TRAPPIST 1e, Kepler 442b, and Proxima Centauri b often appear near the top of most Earth-like lists. Others, like KOI 4878.01, score even higher, though some remain unconfirmed. These rankings change as data improves. They remind us how little we truly know about the surfaces, atmospheres, and climates of distant worlds. Some planets orbit within their stars' habitable zones, where liquid water could exist. Kepler 186f lies near the cooler edge of its star's habitable zone. With the right atmosphere, water might remain liquid there. Kepler 452b circles a Sun-like star and may have spent billions of years in a stable, temperate orbit. In both cases, the presence of water is possible, but unconfirmed. Atmospheres remain unseen. Surfaces remain hidden. Possibility for now is enough. taken together, these ideas suggest something subtle. Earth may not be the peak of habitability. It may be one successful outcome among many possible and perhaps better arrangements. Worlds with longer-lived stars, thicker atmospheres, gentler climates, more time. Life does not seek perfection. It seeks stability. Somewhere in the galaxy, under an older, calmer star, there may be a world where life spread easily, where ecosystems grew dense and rich, where extinction was rare, where time moved slowly. We may never visit such places. We may never see them clearly. But knowing they might exist quietly expands our sense of what life can be. And as you rest now, the universe continues its patient search, not for worlds like Earth, but for worlds where life can truly flourish. Earth remains our home. Unique, precious, alive. But it may not be the universe's finest experiment in life. Somewhere under older stars and calmer skies, there may be worlds where life did not struggle quite as much to exist. Worlds where time moved slowly and life had room to flourish. As you rest now, remember that the universe is vast, patient, and full of quiet possibilities. And somewhere, life may be sleeping under skies even kinder than our own.